Thanks for having me here today at Pulsar Summit. And yeah, today I just talking about a project called Trino. You may or may not be aware of Trino. I like to call it the ludicrously fast query engine. Yeah, so Trino is a project that stemmed from or basically that branched off of a previous version of Presto. So a lot of you may be aware of a project called Presto, and both projects, Trino and Presto, run federated queries across multiple data stores. And for those that are not aware, these projects power this piece of Pulsar called Pulsar SQL. There's this whole confusion about kind of in the documentation in Pulsar, you see Presto right now, but then we're talking about Trino today. So we're going to get into some of the background about when Presto actually split off into Trino and why you're now moving on to Trino. And for those that may not even know, like there's, depending on what Pulsar version you're on, you may actually be using Trino and you just don't even know it yet. Quick introduction of myself. My name is Brian Olson. I am a developer advocate at Starburst. We build a enterprise version of Trino, and I'm also a open source Trino contributor. If you need to talk to me after the talk today, I'm also on Twitter at bitsonDataDev. So without further ado, let's move on to the quick overview of what we're going to be talking about today. So to begin with, we'll talk a little bit about Pulsar SQL, and actually I want to do a quick bird's eye view of Pulsar, because I know there will be a couple people coming into this talk from the Trino side of things. That will kind of motivate the architecture that we're going to talk about that's being used right now, that originally used Presto and eventually translated into Trino. And so we'll then dive into this whole Presto versus Trino, like which one were we using, does it matter, and like what's the whole point of Presto in the first point anyways, for some of you that are coming from the Pulsar side of things. And then we're also going to talk about a specific strength that Trino has called query federation. And then we're going to do a quick bit of looking forward into what this means for us as two separate communities. So to start off with, Pulsar SQL, and in particular, like Pulsar, is a streaming system, but you could also look at it as an event store. So it uses Apache Bookkeeper to store these segments. So you can think of these segments as kind of like fragments of any particular topic or message that you're writing, and it splits it off and writes them into separate data stores. So in particular, the primary storage is Apache Bookkeeper. And this is just like a kind of a traditional write-ahead log kind of way of approaching the database. But then if you want to later on, you can actually kind of archive this storage, these segments, and kind of basically move them over to a kind of more persistent object storage that's a little bit cheaper in the long run if you're trying to save this data for years and years after they've been written to the event store. So you have this historical data that could be kind of sitting around for a long time. And initially, Pulsar really was just an event stream and was very ephemeral, did not have much ways for you to really take advantage of the data being stored there other than just reading it out and moving it into some other database so that you can actually run the analytics afterwards. So it was kind of something that left you wanting, saying, okay, well, what if we don't want to just have to dump all this data that's already sitting in Pulsar out into a whole other system? Why not just make there be some sort of way that we can actually run queries on top of the data already sitting in Pulsar? So so a while back, Jerry Pang from Splunk. So he basically proposed PIP 19 back in August 2018, and was basically suggesting that why not have this capability to do so. And so in order to do that, there needed to be a couple things. So Pulsar out of the box does not enforce there to be any type of schema over the database. So To do so, you need to use what's called a schema registry. This is something that was already existing in Pulsar at the time, and all it does is it basically stores in another segment in Apache Bookkeeper. It stores this schema information, which is defined in Avro, so that whenever data gets inserted into the stream, it's going to adhere to this particular schema, and you know that all the data that is residing inside of this particular topic is going to follow a particular schema. And this is something that's required by a system like Presto or Trino, because Presto and Trino, first and foremost, is ANSI compliant, and they are going to require the data to be represented in a tabular format, and that data has to adhere to a particular schema. So this is what the new version of like Pulsar SQL looks like now, with Trino set on top of it. So you have this new rhombus over here, and it is basically sitting there talking directly to a broker. And that broker is going to give back the schema as well. So that way it will inform Trino as to what the schema is for all of this data. And then as well, give it the ability to use the connector and pull that data from various brokers across that have the different segments for that topic, and pull that into the various workers of the Trino cluster. Now, a couple of folks that were using it for very specific use cases started to request, I think in March 2020, an issue was created, issue 6605, to go from Presto DB. And at the time, this is just to make things even more confusing, Trino was also still being called, going under the banner of Presto, but it was just kind of being called Presto SQL. So and the issue comes in to say basically change from Presto DB and move to Trino. And that was requested in March. Yuya Ibihara, which is one of our maintainers on the Trino side, ended up doing this update in July of 2020. And so at July, we basically, any version from that point on was actually using Trino, even though it has the name Presto inside still inside of the version. So you'll see, instead of saying Presto DB, you're actually using internally a version of Presto called Presto SQL. And that's actually Trino. That's just Trino before it had to do this rebrand. So December 2020, Trino rebrand had to happen because, and we'll talk about that reasons why here in a little bit, but the Trino rebrand happened, and June 2021, which is right now today, Pulsar community ultimately donates this Trino Pulsar connector, and this was done by Marvin Kai. He's going to be doing the demo later today. This was donated by the community to Trino, and now the Trino community is ultimately going to be maintaining this. So yeah, why don't we just go ahead and take a step back though real fast. I've been using Presto and Trino pretty interchangeably, and I kind of explained, why that is. But, today's talk is about Trino. Why are we talking about Presto? And so why don't we just go ahead real fast and take a quick overview at what is Trino and what came about, or basically what events unfolded to get us to where we are today, kind of talking about both Presto and Trino.
Trino is not a database. The key word there, query engine, is going to be delineating it from a particular database, that because we do not store data. We actually rely on data sources that are already storing this data to basically hold the data, and then we speak the language of all these different data sources to perform joins across them. Let's dive a little bit into Hive in particular and talk about some of the things that Trino was initially created for. So back in the early big data days, HDFS was open source software that everybody was jumping onto, but nobody really knew how to really use it super well and efficiently. And you had to hire on people that knew how to use MapReduce and how to write the custom code for your MapReduce operation just to be able to use your data. So what Hive did initially was create a SQL on Hadoop solution that exposed a SQL-like syntax called HiveQL and ultimately mapped that SQL statement into a MapReduce operation. So this was definitely a step in the right direction. It got companies into a bit of a better situation where they could actually query their data, but things were ridiculously slow and unnecessarily so. One anecdote from Facebook was it was a good day for a data scientist to actually get 6 queries run in a single day. So this was definitely high in demand, like needed to be quick, needed to be fast, and ultimately still needed to support something as ubiquitous as SQL. So Presto came around about 4 years after Hive was created, and it was also developed at Facebook by Martin Traverso, Dane Sundstrom, and David Phillips. And so they aimed to really solve for this slow querying mechanism that existed in Hive at Facebook. So the philosophies around this, whenever the founders put this together, was they really believed in open source in terms of how to make a project successful. So it was so important that they had feedback from a community that could basically tell them if they were basically missing certain use cases or needed to grow in certain areas. So around 2018 and maybe even a little bit before that, Facebook started to kind of put a lot of constraints on how individuals would contribute in open source. And ultimately, they unilaterally made a decision to put rules around committership that favored a lot of things for Facebook, and particularly made it a Facebook-centric type project. So at that same time, Martin, Dane, and David left Facebook so that they could create a branch called Presto SQL. And the cool news is that the community followed in the kind of assumption that Presto DB for Facebook would just kind of lie dormant or basically go away. That didn't totally happen. What basically came about was Facebook revised that rule, and ultimately that there is some activity still going on in the Presto project, but it is still largely a Facebook-centric project accomplishing what Facebook needs versus the open source community at large. So what happened was PrestoDB was, which is the Facebook version of Presto, got put under the Linux Foundation, and the Linux Foundation decided that they wanted to go forward and assert the trademark of Presto at that point. And so Presto SQL, which is the banner that we had gone under with Trino, was now forced to rename. And that is why we have this cute little bunny that is named Commander Bun Bun, and why we have the name Trino. We're dealing with the same software that was developed over the initial 6 years, and now has since then become much more active than the original Presto project. Same people, same community, and just under the shiny new name of Trino, which is short for Neutrino. So the thing to point out here is that although there's still some affiliation with Facebook, companies don't really ultimately run open source projects. It's actually the people that are involved in those projects that are what drives it. And so you can see that is very relevant in the graph here, where that shows the Git commits of the Trino project over the Presto project in the last 2 years since the split has happened.
So last little bit that I want to talk about with Presto and Trino is talking about query federation. So this actually makes it really clear, talking about this, one of the real big benefits that initially drove the use of the Pulsar connector to set up the querying Pulsar to begin with using Pulsar SQL. But then this also opens up a whole other set of capabilities that you can do to federate queries across not just Pulsar, but other databases. So let's talk a little bit about the history of what brought this about. So, Facebook actually was where Presto was created, and Facebook typically has their own version of any type of system that is open source. There's also a Facebook kind of internal version that is being maintained, and a lot of big companies do this because they have the engineering capacity to do so. And so when the engineers, when Martin, Dane, and David were creating Presto, they had this issue when they were initially trying to have it query from different systems. They had to, and they also wanted to basically make this usable by open source. They had to make almost like a special custom code to talk to the Facebook version of any system that they were talking to, plus the open source version of any source they were talking to. So what they devised was there needed to be kind of an abstraction or interface layer between these called the SPI. And these individual connectors, all the code that's kind of customized going out to all of these individual different systems, these could all get abstracted away just talking to this layer called the SPI. And so so this was super useful. This ended up actually being one of the cornerstone use cases of not only Presto but now Trino. And so so this also ended up being kind of the Pulsar-centric use case of Pulsar SQL. So, so one thing that to be noted here is that this is a kind of an inverse way that was usually that this was set up compared to how Trino is usually used. In particular, most people that are using Presto and Trino is they're using it as kind of the primary access point for all of their different data sources. Whereas actually Pulsar, and when Jerry put this together back in 2018, they did this as a kind of Pulsar centric way of viewing the data through Pulsar using Trino as kind of an embedded service within Pulsar. So this was kind of different from how usually it's used, but it's actually a very solid way to use it, right? And so anybody who's using Pulsar does not really have to know that Presto or Trino exists, other than the fact that they have to use a couple services to start that up. Now you can think about this expanding to other databases, for instance, the Trino-centric use case, where now you're not only using it internally to just query the using Pulsar SQL to query over Pulsar bookies, as well as now some S3 storage. Now you can actually query Pulsar as well as, say, a NoSQL database like Mongo, a traditional database like Postgres or MySQL, and then you could also, still be pulling in data from your data lakes using the Hive connector, which can ultimately connect you to your S3 stores, MinIO stores that are maybe on-prem, any cloud storage really from that connector. So this now ends up not just being able to limit you to just doing analytics over just your Pulsar data. You can now do analytics and perform actual joins, saying, hey, let's join data in my Pulsar, sitting in my Pulsar event store. Now join that with data that's sitting in MongoDB and act like they're just two separate tables. So that's pretty neat. And in fact, Marvin is going to be demoing this using MySQL and Apache Pulsar. So he's going to start out pulling in some taxicab data, just talking to Pulsar, and then he's going to then do a secondary part of the demo where he's actually talking and running a federated query over both Pulsar and MySQL and visualizing it in SuperEdSet. So let's go check that out.
Here's a demo of using Trino with Pulsar connector to query data in a Pulsar system. First, let's start a Pulsar standalone deployment. While it's starting, we can take a look at the Trino Pulsar connector config, which contains some of the most important config and for connecting with Pulsar or tuning the performance. Now it's started. We then start the Trino standalone deployment. It's up now. So you can see Pulsar is already recognized as a catalog in Trino. So we can see here each Pulsar namespace and tenant combination is mapped to a schema in Trino. And then a topic in Pulsar will be mapped to a table in Trino. if we can find any tables. Actually, there is no topic in Pulsar now, so we couldn't see any topic. Now I'm gonna ingest some data into Pulsar. Here using MYC taxi data, which is write record of MYC green and yellow taxi. And here's the schema like vendor ID, pickup, drop-off time, record, location. Then I'm gonna start the ingestion. Now it's ingesting at speed of 10 record per second. And now if we check again, we will be able to see these two topics show up as a table in Trino. And I'm gonna use this super cool visualize tool. And then let's, I've already hooked up this superset with Trino, so I can see all the schema and table here. And let's try to see a schema. You can see the schema is loaded here. It automatically read the schema of the Pulsar topic and map to a Trino schema. And then let's try to run some query. Here we are grouping the record by pickup and drop-off location and order by the count to see popular pickup and drop-off location here. As we are still ingesting data into Pulsar, if we just rerun the query, we can see the number or the count is actually updated. And we can also do a cross-drawing between two different topics or two different Trino table. So now we are cross-drawing green taxi data and yellow taxi data and join with the same pickup location and drop-off location to see how often they kind of cross each other. And we can see like there's 160 green taxi and yellow taxi have met each other in this drop-off and pickup location. And again, it's still ingesting data. So if we just run again, we see the updated result. And here is just a static example. Probably a more interesting example would be an e-commerce example. In the modern e-commerce website, customer information are usually stored in relational database system where we can rely on the asset guarantee provided by RDBMS. And with a modern microservice architecture, when we break down the monolithic order service where we need to check inventory and then check payment, check credit card, and then send notification and then call package service. Probably we want to break all these things up into the microservices, and then they can communicate with each other. And it would be like a architecture like this. Order service would just check inventory, and if the order can be fulfilled, it would just send a message to a message service with strong persistent guarantee like Pulsar. And then all the downstream service would just consume message from the message queue and do a process. And this way we can just decouple different systems, and then they can just communicate asynchronously, so they can each process at different speed or run at different scale, and they can each do their own update or development. And our message system would be a great buffer between different systems, so we can protect the downstream system. And in this case, if we have order message in Pulsar and we want to query this information along with the customer information we have in a RDBMS like MySQL, we use the awesome federated query provided by Trino. Again, let's ingest the data first. So we are ingesting the TPCH sample ordering data. And let's see. So the table is loaded. By the way, the old green and yellow taxi data is automatically cleaned up by the system because it recognizes the topic is idle. So we have the order system ingested into Pulsar. And let's just check the schema first. So it has all the schema, and the key would be customer key, which is what we're going to use to join with the customer data we have in MySQL here. So we are joined with MySQL here and to see how many orders each customer has made.
Okay, thank you so much, Marvin. That was fantastic and really eye-opening. Hopefully a lot of you see the power of being able to run this federated query over both your Pulsar data and maybe some operational data store like MySQL. So let's really quickly take a step back and now think about moving forward. What does this all mean? So now Trino is getting the Pulsar connector. We're going to be maintaining the connector moving forward, but this is still going to be kind of a joint effort, just because we're maintaining this and within the connector and the Trino repository. This is kind of, I would like to kind of make this a call to action for any developer who knows Pulsar really well, that's interested in Trino. If you are really thinking this is a cool concept and you want to contribute, we're at ground zero here. Right now, there's only read capabilities coming from Pulsar. Version 2 and future iterations wanted to add the writing capabilities to this connector. So this is one of many of the different things that you could actually do to kind of expand upon the existing abilities that we have with this connector. So I wanted to make a quick pitch for this community that we have on the Trino side. If you're interested in this, we have a Slack channel. Let's just go to trino.io/slack.html. I do a broadcast, which is like a kind of half Twitch broadcast slash also it gets streamed into a YouTube showing and also podcast. And so we just call it Trino Community Broadcast. Check out some of the older shows that we have there. We're also really looking forward, hopefully, to having a few folks from the Pulsar community to join us. So if you are interested in joining the Trino Community Broadcast, especially if you start doing some really cool stuff with the Pulsar connector, you can join us on the show. We'd love to have you. And then we also have Trino virtual meetups that are starting to pick up now. If you want to contribute to Trino, and especially in this particular Pulsar area, go to trino.io/development. And then, if you want to check out blogs or even write a blog about, some cool stuff that you're doing, go to trino.io/blog just to see what everything's going on there. And you can actually reach out directly to me. Again, I'm at Bits on Data Dev. I'll have that in the next slide here. And you can reach out directly to me or even find me on the Slack channel. And then finally, there's, we also have docs. If you want to improve upon the Pulsar docs, please do that. One last little pitch. We have Trino Summit coming up September 15th. It was going to be both September 15th and the 16th, but that has changed to a hybrid event. So we will only be doing a one-day event, but it's going to be partially live, and the other half will be streaming on one day. So ignore the September 15th to September 16th bit there. But definitely check that out at starburst.io/Trino Summit 2021. Thank you all for joining this presentation today. I hope it was eye-opening, and I really look forward to a lot of the synergy that we have going on between Trino and Pulsar. Thank you all so much for your time. Please give us a star on github.com/TrinoDB/Trino on our repository. And you can always, again, find me at Bits on Data Dev.